this video, we're talking about how to find the distance between two coordinate points in three-dimensional coordinate space. And in this particular example, we've been given two coordinate points, the point 2, 0, 1, and the point -5, -6, -5, and we want to find the distance between them. So the first thing we need to realize is basic, but we're dealing with three-dimensional coordinate space. So if I draw space here like this, where this is the x-axis, the y-axis, and the z-axis, like this, and we wanted to plot these points in three-dimensional coordinate space, what we're talking about here is a point in the form x, y, z. So x is equal to 2, so if we come out here, we start at the origin, we come out along the x-axis maybe 2 units, so this distance is 2, and then the y value is 0, so we don't move in the positive or negative direction of the y-axis at all, we stay right here, and then the z value is 1, so we go up along the z-axis 1 unit, and maybe we get to this point right about here in three-dimensional space, and that would be the point 2, 0, 1. And similarly, we could plot the point -5, -6, -5. But we have these 2 points, we want to find the distance between them, and when that's the case, we use this formula here for distance, d, and all we do is plug in our coordinate point values for these values of x sub 2, x sub 1, y sub 2, y sub 1, and z sub 2 minus z sub 1. And the most important thing here is just that we stay consistent with our points. So for example, if we call our first point 2, 0, 1, we call this x sub 1, y sub 1, and z sub 1. And then in our second coordinate point, we call this x sub 2, y sub 2, z sub 2. We just need to make sure that we stay consistent. So all of these will be the variable sub 1, and all of these values will be the variable sub 2. So one of your coordinate points is going to need to be x sub 1, y sub 1, z sub 1. The other coordinate point is going to need to be x sub 2, y sub 2, z sub 2. So we're going to have distance is equal to the square root of quantity x sub 2 minus x sub 1. So if we take x sub 2, we say -5 minus x sub 1, which is 2, and then we're going to square that value. Now it doesn't matter which coordinate point you pick to be x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, z sub 2, as long as you're consistent. So we could have flipped these values and we'll still end up getting the same result. The important thing is that you just stay consistent. All the 1s are in this point, all the 2s are in this point. So here we have then plus y sub 2 minus y sub 1, so -6 minus y sub 1, which is 0, so minus 0, quantity squared, plus z sub 2, which is -5, minus z sub 1, which is 1, quantity squared there, and then we're going to just call this the square root of everything like that. So then when we simplify here, we're going to get distance is equal to square root, -5 minus 2 is going to be a -7, -7 squared is going to be 49. Here we're going to have then -6 minus 0, which is -6, -6 squared is going to give us a positive 36. And then here, -5 minus 1 gives us a -6. Squaring it gives us a positive 36 again. So that's how we're going to simplify underneath the square root. And then when we add all of those together, we're going to get d, or distance, is equal to the square root of 121. And of course, the square root of 121 is 11. So we're going to get distance is equal to 11. Now you might say, when you take the square root of 121, you have to call this positive or negative 11. But because this is a distance, it's an actual distance between 2 points in three-dimensional space, it's irrational for distance to be negative. We can't call a value for distance a negative value, so we have to use the positive value. So you can just go ahead and assume the positive value from the square root. And in this case, distance is 11 units. So it's 11 units between the point 2, 0, 1 and -5, -6, -5. And that's how you find the distance between 2 points in three-dimensional space.